Crispy, crunchy food is awesome. It shatters in the mouth, catering to our childish desire to destroy stuff. It's why we like fried chicken, potato chips, good bread, and sugary hard candy like toffee. At a molecular level, crispy food has a lot in common with this bottle. It's made of glass. So there's water in everything you'll ever eat, along with a lot of other molecules that are much bigger than the water itself. Now those tiny water molecules act like ball bearings, allowing the bigger molecules to slip and slide past each other. That ability for the big guys to move around is what makes food squishy, soft, and runny. When you poke, pour, or cut those types of foods, they give way. Crispiness comes from foods that can't bend so well, so they break. Now we have three ways of making foods crispy. We can add more big molecules to jam things up at a molecular level, like starch and proteins. We can remove water, removing the ball bearings, or we can let the food cool down, which slows molecular motion down and causes sort of a traffic jam. If we use the right combination of those three factors, that traffic jam stops everything completely. That point's called a glass transition, the magical moment of crispification. Now, making that molecular traffic jam happen is pretty easy. Maintaining it is the tricky part. When we add big molecules to food, they stick around. And we're good at controlling temperature in the kitchen. So the main culprit for soggy food is usually water. That's why we seal potato chips in a bag. It takes water out of the equation until we're ready to eat them. Keeping chicken crispy is way harder because the water that makes the meat juicy will ruin the crispiness of the skin sooner or later. Understanding these dynamics is an important way for all of us, from master chefs to casual home cooks, to prepare ourselves for success in delivering this sound to the table.